Hey, Algebra 2, welcome back. Welcome to a new chapter in Algebra 2. We're going to go ahead and get started with Chapter 5. We spent quite a bit of time on Chapter 4. And before we even kind of go on from that, I want you to just kind of take a second to just pat yourself on the back, right? Because you survived Chapter 4. Chapter 4, it was review from Algebra 1, but again, Algebra 1 for you guys was about 2 years ago. Might be a little bit too much to ask you to remember all that stuff in detail, right? And quadratics are pretty difficult. So I'm happy that you're still here. I'm happy that you made it. It's okay if there's still some things that you're a little confused about. I think we're ending on a good note with the quadratic formula, something nice and light before we kind of continue with this chapter 5 stuff, okay? So pat yourself on the back. You did it. Let's just keep moving on, okay? It's a crazy semester. Let's go ahead and just try our best to keep going. We're going to go ahead and start chapter 5 with some properties of exponents. If you notice, I kind of changed the layout a little bit. I'm using a darker background. Hopefully that helps. I know when I'm kind of recording these videos, staring at the white background is a little harsh. So let me know what you think. If this is a little too dark and you can't really see well, then just let me know and we can kind of go back to the white. Our objectives for this section using properties of exponents, we're going to go ahead and relearn these properties, right? These are hopefully also review for you. We're going to relearn them and how to use them. And so we're going to evaluate and simplify expressions using those properties. And we're going to relearn how to convert a number to and from scientific notation. So that's going to be a big part of our section 5.1 as well, is to work with scientific notation, has a lot of similarities to these exponent properties. And then we're going to multiply and divide numbers in scientific notation. Okay, and we're going to notice that a lot of the properties are being used there. So speaking of properties, let's go ahead and just review them. Okay, let's kind of recall what they are. So each of these properties has a name associated with them. We're not gonna take time to kind of talk about the names. We're just gonna go, okay? We don't really need to know the names or memorize them at this point. So one of our first properties involves multiplying two variables or two things with exponents attached. So what happens when we do that? Notice that it has the same base, right? I can't really do this property if these bases are not the same. It's going to become a to the m plus n power. Okay, so after we do each property, I'm going to go ahead and show you an example. So if I have like 5 to the third power times 5 to the fourth power, what does that equal to? That's going to be equal to 5 to the 3 plus 4 power, which is 5 to the seventh. And if we calculate that, we get 5 to the power of 7 is a really big number. It's going to be 78,125. Okay? So then notice that we took 3 and added it to 4. And if you're wondering why, well, imagine yourself writing this out 3 times, 5, 5, 5. And imagine yourself writing this one out 4 times, 5, 5, 5, 5. And it's all being multiplied together. When you gather this all up, how many 5s do you see? 7. Okay, that's why we use addition there, if you were ever kind of confused as to why that property works that way. Okay, next one. We have a to the m to the power of n. So we're taking a thing raised to a power and raising it again to another power. What happens when we do that is we get to the a to the m times n power. All right, so let's try, we have 3 squared to the third power. So we do 3 to the 2 times 3 power, right? 2 times 3. And that's going to be 3 to the 6th power. And when we punch that into the calculator, we get 729. Okay, same kind of idea here. Remember, when we do something to a power, we write it out that many times. So 3 squared to the third, that's 3 squared times 3 squared times 3 squared, right? And then we do it one more time with all these exponents. We have 3 times 3 times 3 times 3 times 3 times 3. So how many 3's do you see? We have 6, right? And that's why the simplification is to the 6th power. All right, so all these rules have meaning. It's not just some random rules I'm having you guys do. They all kind of come from somewhere, okay? Hopefully that makes sense. Next one, I take two different things, right? And when I say thing, I can be referring to a variable or to a number, right? We're just kind of using generic letters for right now. And I raise it to a power, then I can go ahead and quote unquote distribute that power. So it's a to the m times b to the m. Do not, because a lot of you guys tried doing this in chapter 4, don't assume that you can do that for these, right? I cannot say that this is a to the m plus b to the m, and this is not a to the m minus b to the m, right? We talked about this in chapter 4. This is a big no. Don't even write it down, all right? Remember, or if you want to write it down and scribble it out with your heart's content just to remind you that that's no, go ahead and do that, right? Don't do that because you'll be a sad math person, okay? That's not the rule. And if you want to convince yourself, do some examples of it. Like do some examples that show you that that's not true. All right, so then let's see how that applies. We have 2 times 3 to the 4th power. Now I could go ahead and I can multiply the 2 and the 3 together. So maybe let's try a different example where it's really more applicable. Let's say you had 2x to the 4th to the 3rd power. Here's the kind of a little bit more of an applicable situation. I distribute that power to each term. This is going to be 2 to the 3rd times x to the 4th to the 3rd, right? And then x to the 4th to the 3rd, that's going to be 2 to the 3rd times x to the 12th, right? Because I multiply those powers using the second property. And then 2 to the 3rd is 8. So we get 8x to the 12th. Let me go ahead and write that in the line above. That way I have room for the next example. We get, I'm going to scrunch it a little bit, 8x to the 12th. Okay, next property is our negative exponents. Okay, so if I have a to the negative m, notice how this becomes 1 over a to the m power. And this has a little bit of a rule. We're gonna kind of assume that a is not 0, okay? Right, because it wouldn't really make sense to throw a 0 in the denominator because then that kind of blows up, right? We don't like zeros in our denominators. So notice that when I do a to the negative m, and let me make sure that that's a little bit more clear that that says a to the power of negative m. Notice how my result doesn't have any negatives in it, right? I don't throw a negative in there just because I see the negative exponent. What happens is it makes me take a reciprocal of what I originally had, okay? So let's see that with a number, 7 to the negative 2. That's going to be 1 over 7 squared. Okay, notice how there's no negative here. All I did was flip it. I took the reciprocal of it, and then I got rid of the negative in my exponent. But then we know what 7 squared is. That's 1 over 49. Okay? So then watch out when you're using your negative exponent properties. I have a to the 0 is equal to 1. Okay, that's another property. And this has also the rule that a can't be 0, right? Because then we end up with 0 to the 0 power, which is scary. We don't even want to, we don't talk about it, okay? It's scary. It's not really scary. It's just something we call indeterminate, which means that it's not undefined. Like, 1 over 0 is undefined. But 0 to the 0 is not undefined. It's what we call indeterminate. We don't really know what it does, okay? Because it can do a lot of different things. But that's another conversation for another day. So, if I take any other number, like say some random big number like negative 89, and I raise it to the 0 power, doesn't matter how big it is. As long as it's not 0, it goes down to 1. I can take 249 million, right? And I can raise it to the 0 power, and that'll still be 1, okay? A few more properties. We got 2 more. We got our division property. So what happens when I take two terms, 2 of these guys with the same base, right? What happens to the exponents? Well, it goes to a to the m minus n, right? Because if I had, as an example, let's say we have 6 to the negative 3, or actually, let's not get into that quite yet. We'll get into that with our examples. I have 6 to the 3rd over 6 to the 6th. Okay, so what happens there is I kind of what's happening is I have 6 times 6 times 6 over 6 times 6 times 6 times 6 times 6 times 6. Sorry, that gets a little redundant. What happens is that some of these divide each other out. These divide out, these divide out, and these divide out, and I'm left with the 3 here. Okay, so let's see how that relates over here. My property says I just write 6 to the 3 minus 6, which is 6 to the negative 3, right? Because 3 minus 6 is negative 3. And then I can use my negative exponent property. That's 1 over 6 to the positive 3. And we know 6 cubed is 1 over, well, actually, maybe we don't know. And in case you don't, you could always plug it into your calculator. But 6 cubed is 216. Okay, and that's what we end up over here. We got 1 over 6 times 6 times 6, which is 1 over 216. All right, so you kind of see how that property plays out as well when you actually do the writing out using the exponents. All right, and one final property, one last one to kind of drive it home, is similar to the distribution property over here for multiplication. We have a property for that involving division. So if I have a fraction or a division raised to some exponent, then I can distribute that exponent to top and bottom. And then here it's kind of implied, but you don't want b to be 0, right? And then I forgot to write that in this one as well. A is not 0 because then we get division by 0. And then here b is not 0 because we don't want division by 0 again. And then the example for this one, let's do 4 over 7 squared. Well, that's going to be 4 squared over 7 squared. And that's going to be, oh, I almost wrote 8. No one saw that. 16 over 49. Okay, and we can't simplify this, so we're good. All right, so that was kind of just a reminder of our exponent properties. Hopefully those are ringing a bell. In the second part of this video, we're just going to do a bunch of examples just to practice this and make sure that we're okay with using each of these properties, okay? So meet me in the next video and we'll do a few examples.